Part two of the atomic theory, again, I'm still in the review portion here, is building on the particle model, is looking at solid, liquid, and gas. Now, this is probably a diagram that you have seen before. I'm going to expect that you have. Before I get into this, I just want to kind of explain the table. And again, this information can easily be found on the internet, but you have solid, liquid, and gas. Let me explain over here. Of course, this says the diagram. You have the arrangement of particles, the movement of particles, and the closeness. So, what we're going to do is we're going to start with, I think let's look at solids first. Now, solids have a really nice arrangement. They're kind of packed close together, okay? You're also going to notice that they don't move, but that doesn't mean there's no movement. They still have a little bit of vibration. So they're in place, but they're vibrating. Lastly, you'll notice that there's a very little space in between the particles. So they are packed very, very close. If we move on to liquids, okay, you will see that the particles are arranged somewhat randomly. They're together, but there's really no fixed structure to it. They do move around each other. They probably have vibration, but they also have the ability to move. And if you think of a liquid, you can pour it. It can move. And the particles are fairly close. Finally, we'll look at a gas. Well, now you're going to see the gas particles are arranged every which way. They are randomly arranged. They move very quickly in all directions. They're shooting all over the place. And this time you have a greater space in between. There is one last thing that I would like you to know about this. It's not on this diagram. There is something to do here with energy. Now, when I look at this diagram of solid, liquids, and gases, I think there should be one more level to this table. You see, the lower the energy, the less movement. And as you increase the energy, or let's say raise the temperature, you get more movement. And let's think of this in terms of water. When we go below 0 degrees, we are removing energy. Of course, the water particles come together, they get stuck in place, they vibrate, but we have ice. If we raise the temperature, raise the energy to above 0 degrees, we get liquid water. Free movement. If we raise the energy or increase the temperature some more, above 100 degrees Celsius, we get the gas state, where the water particles can move every which direction. So please keep in mind that the particle model is really affected by the energy or the temperature, and that's going to help dictate the state that you are in.